Okay, in this video we're going to solve tutorial for chapter 3 and we're going to solve the problem solving. So we'll start by solving problem like for projectile motion. So this problem number 3 is a ball is thrown horizontally from the top of the building, which is 0.10 kilometer high. Okay, the ball strikes the ground at point 65 meter horizontally away from and below the point of release. What is the speed of the ball just before striking? So the ball is thrown at a height above the ground. So the building is like this. Building is 0.10 kilometer or 100 meters. If you take this kilometer, the ball strike the ground and the ball is dropped from that height horizontally. Okay, and it fall like this, and it fall horizontally 65 meter. Okay, and we wanted to know the velocity just before striking the ground, or speed. We wanted to know the speed. So if you know speed is nothing but the magnitude of velocity. So vx squared vy squared. So we wanted to know the velocity, speed, or the velocity component of the x and y, and then we take the magnitude to get the speed. Okay, so we are given, this is our coordinate system, this is our origin. So when we decide our origin, this is our x, this is our y. So this direction is the minus y. Okay, so our building is in the minus y direction. So this is minus y. Okay, and the ball is thrown like this horizontally. Okay, so we have, so it's thrown horizontally. It's thrown horizontally, it's v naught of x has a component of velocity, but we don't have the y component, which is 0 in that case. Okay, and this is the positive x. So this is your x, which is the range of the projectile or the distance is covered. Okay, so what is now the x? So we wanted to know the vx and vy, vx and vy. So what's this x equation? So x is x naught plus v naught of x t. So this is 0 and this x is 65. So we get v naught of x t. So we don't have v naught of x and we don't have t right now. So if we know like t, we can have v naught of x, which is the x component of the velocity, or vx component of the velocity. So if you wanted to find t, you use always the y equation, which is y naught plus v naught of yt minus 1/2 gt squared. So at this height, so this height is this, which is minus 100 y, and y naught is 0. Your vy naught is 0 as well. So we get minus gt squared. So we get minus 100 minus 1/2 9.81 t squared. Minus minus will be cancelled out. So we get t square 200 divided by 9.81. So t is, we get t 200 divided by 9.81. So we get square root. So we get plus or minus 4.5, and we take the positive time, which is 4.5 seconds, because time goes in forward. Okay, so we get this t. Now we get the vx, which we're going to put over here. So v naught of x is 65 divided by 4.5. Then you have v naught of x, which is we got 14.4 meter per second. So this is your x component of the velocity. Okay, so this is your vx, which is 14.4 meter per second, because the horizontal motion along the projectile is constant, so this motion is constant. Now we wanted to calculate what is vy. So we can calculate vy is v naught of y minus gt. V naught of y is 0, and we get 9.81 multiplied by 4.5. So we get vy minus 4.4 meter per second. So now we have vx and now we have vy. So our speed will be square root of vx squared, vy squared. So we will get 14.4 squared plus minus 4 squared and the square root. So we will get the answer 46.5 meter per second, which is 47. So this is your answer. Now in problem number 4, a rock is projected from the edge of the top of the building with initial velocity 12.2 meter per second at the angle 53 with the horizontal. The rock strikes the ground with the horizontal distance, this is your x, from the base of the building. How tall the building is. We wanted to know how tall the building is. So it's just like a similar problem, but from the previous problem. So we have this is the ground, and this is the building height. Okay, so a rock is projected with some initial velocity, with the angle theta, and having initial velocity 12.2, which is your v naught. So now first you see to decide your coordinate system. This is your coordinate system. So at this point your x naught is 0, your y naught is 0, your ax is 0, ay is minus g. Okay, and this is your theta naught, which is 53 degree. Okay, and we wanted to know what is this height. We wanted to know this height. Okay, so now we have this. Now we're going to resolve the x component of the velocity, which is v naught of x cos of theta naught, v naught of y, v naught sine of theta naught. So we have v naught of x sine of theta naught. So it's 12.2 cos 53 degree, which is nothing but 7.3 meter per second, and v naught of y is 12.2 sine 53 is 9.7 meter per second. Okay, now we're going to analyze the x and y equations. What is our x equation? Is x naught plus v naught of xt. So x is v naught of xt because this is 0. Okay, so this x is 25 because it falls 25 distance, which is this x. This is your x. So we get x is 25, v naught of x is 7.3 t. So t is 25 over 7.3. So we get t, which is 3.4 second. Now we're going to analyze the y equation. So what's y equation? Y is y naught plus v naught of y t minus 1/2 gt squared. So your y, we wanted to know this height. Okay, so this is minus h, this is 0, 9.7 multiplied by 3.4 minus 1/2, 9.81, and your t squared is nothing but 3.4 squared. Okay, so we get this height, which is 23.7 meters. Just calculating this and subtracting this, so we get 23.6 23.6. This is your answer. Okay, so now question number 5. An object moving at a constant speed requires 60 seconds. Requires 60 seconds to go once in a circle. Six means 6 seconds, not 60. This is 6 seconds. Once in a go around a circle with a diameter. This is the diameter. This is the once, which is the time period. What is the magnitude of instantaneous acceleration? So we wanted to know instantaneous acceleration, radial acceleration, or the centripetal acceleration at this time. So you are given time period 6.0 second, diameter is 4 this meter, and your radius is diameter divided by 2, which is 4.0 divided by 2. So r is 2 meters, 2.0 meters. Now, what's your radial acceleration or instantaneous acceleration? So your instantaneous acceleration is nothing but v squared divided by r. And what is the formula for the like the velocity or in terms of the time period? So your time period is 2 pi r divided by v. Okay, so your v is 2 pi r divided by t. So you find v equals to 2 into 3.146, 2 divided by your 6. So you will get v, which is 2.2 meter per second. And when you substitute this v, 2.2 squared divided by 2, so we get 2.2 squared divided by 2, we get 2.42. So the acceleration is 2.42 meter per second squared. So we don't have any option, so we have option F, which is 2.42 meter per second squared. This is your answer. Now the next question is, a car travels in a flat circle of radius r at a certain instant of the velocity, the car is 24 meter per second west. So the car is moving in a flat circle of radius r, and its velocity towards the west. So we have east, west, north, and south. So its velocity along the west, like this, it's moving in this direction with 24 meter per second, and the acceleration of the car has components along east. So east, so it has component along east, which is this component of the acceleration, which is 2.4 meter per second, and this component which is along south, which is 1.8 meter per second squared. Okay, so we wanted to know what is the radius of a circle. So we wanted to know r. So at certain instant, so we wanted to know the instantaneous acceleration, because it's certain instant. So your instantaneous acceleration is nothing but v squared divided by r. So when the acceleration is instantaneous, so we only consider the component which is perpendicular to the velocity. So in that case, this is your velocity direction and this is your perpendicular component, which is making an angle 90. So now r is nothing but v squared divided by a instantaneous. So v square is 24 squared divided by v instantaneous, which is 1.8. So 24 squared divided by 1.8, it's 320 meters. So r is 320 meters, or we can divide it by 1000 to convert it into the kilometer, which is 320 divided by 1000, because 1 kilometer is 1000 meter, divided by 1000 kilometer, which is 0.32. So this is a correct answer in this problem. Okay, the problem number 7, the speed of a car increases at a constant rate. Increases, it means speed is increasing from 10 meter per second to 40 meter per second. So this is your given velocities, which is v1 and v2. Okay, then at time t second, as rounds the circular horizontal curve of radius 80 meter. So it has a radius of 80 meter and it's changing its speed over here, which means this is a non-uniform motion. Determine the magnitude of the total acceleration. So we wanted to know the magnitude of the total acceleration. So when the speed is not uniform and the speed is changing, so we have the acceleration, which is the total acceleration, is the parallel component plus the perpendicular component. And what is the magnitude? Is a parallel squared or a perpendicular squared. So this is what we wanted to know. Then how do we know? We calculate a tangential. A tangential is just the d by dt v magnitude. Okay, and v perpendicular, which is the instantaneous acceleration or radial acceleration, which is v squared divided by r. And we can calculate this thing from this, because we have this v1, v2, and we can calculate the average velocity, which is v2 minus v1 divided by t2 minus t1. So we will get this is 40 minus 10 divided by 10, so we will get 30 divided by 10, which is 3 meter per second squared, and v is in that case is 40, so we take as the 40 and then it's moved with the constant acceleration, and then we have 40 squared divided by the 80 is the radius, so we will get 20 meter per second. So now the magnitude of the acceleration is nothing but this squared into this squared and the square root. So we have 3 squared plus 20 squared, which is equals to 20.2 meter per second. So this is your magnitude of the acceleration in this problem. So I'll see you in the next video for remaining problems.